Hey, what's up guys, my name is Cherno. I haven't done one of these reaction videos in a while, but I was just, working, aka just browsing YouTube this fine morning, and this popped up on my feed. Unreal Engine 5.2 Next Gen Graphics Tech Demo, State of Unreal 2023. This is from GDC this year, which is currently going on. I kind of miss GDC. I went to GDC in 2018 when I was still working for EA because they flew me out there, and I remember specifically going to an Unreal Engine presentation, like in the flesh in San Francisco, and this was when like real-time ray tracing was like just coming out. So it was really, really cool to see. I think they showed like the Stormtrooper demo back then, like some kind of Star Wars scene. It was really, really cool to see that real-time ray tracing. So it was crazy how much has changed in 5 years. I mean, I guess 5 years is a decent amount of time. But anyway, Unreal Engine 5.2 Next Gen Graphics Tech Demo. Haven't seen this yet, obviously. Let's take a look. I'll have the video linked below.
Added several new features to the engine to support foliage rendering, and the Fortnite team used those features to ship Battle Royale Chapter 4. At the same time, Jacob over there and the team at Quixel were experimenting with what's possible for photoreal foliage environments. As well.
I immediately want to add a few things here. Right, so first of all, foliage rendering is not something that Unreal Engine 5 really supported in terms of with all of its latest nanite and lumen features out of the box. Because for those of you who are like rendering engineers or enthusiasts, I guess, who understand how that works, foliage rendering, in fact, many different parts of a scene's rendering technology, especially like not the standard meshes and geometry, but like all the kind of almost effects. So things like particles, things like, well, foliage, obviously, things like, I don't know, water, like all these kind of special effects that aren't just like, and I'm calling them special effects, even though that is usually a term that we use for other things, but all of those kind of special rendering scenarios, they can be an entirely different beast that has to run through a completely different pipeline, has like lots and lots of specific edge cases and specific ways that things have to be handled. So naturally, when you introduce something as big as lumen or nanite, it's like each section of the scene's rendering, like the foliage versus the normal kind of static meshes or dynamic meshes or whatever, each kind of area needs like almost its own department to just be like, okay, we're gonna make this work. We're gonna make this compatible. We're gonna run this. Now, I don't literally mean department like within the company that needs to work on that. Usually, you'd expect it to just be the team that obviously makes like the lumen tech in the first place to add it to like all the different areas. But my point is, something might run out of the box and work really well in like the base case, but then you try and make it work with foliage rendering, and you're like, ugh, nothing works. So that was just something I remember not being a thing. I feel like they added this in 5.1 though. Maybe I'm wrong. Haven't been following along with this too closely, but it definitely wasn't around in Unreal Engine 5. Like nanite or lumen like didn't quite support foliage rendering in the same way that it obviously does now. Now, the other thing I want to note is Quixel, right? So part of the reason why these scenes look so detailed and so amazing is because Unreal Engine made the very, very wise decision of buying Quixel back in the day. I guess I should say Epic Games did. And Quixel is this huge library of assets. So like these plants that you're seeing, like the kind of art assets that were used to construct this scene are from Quixel. And the reason why that's such a smart decision and it's just such a good thing to do is because at the end of the day, a game engine is like absolutely nothing without assets. Like if you don't have good art assets that you can pop into the engine to create scenes, you're gonna get nowhere, right? The engine's only gonna be as good as the assets that are fed into it. It's kind of like having like a state-of-the-art photo printer. Like you have the best photo printer in the world, but you're just creating little images in Paint and then sending it to the photo printer. It's like, yes, like they will kind of look good. Like the color will be good and like it'll be what you make it, right? Like it'll still look kind of good in a way, but obviously like if you compare that to, a 100 megapixel photo that an artist like some professional photographer took of like, I don't know, mountains in the real world or something, and they color graded it, they made it look perfect, and you feed that through your photo printer, obviously that's going to look so much better. So a lot of what you're seeing here is obviously also thanks to the amazing art assets that Quixel provides, and just the artists in general that put this together, because that can't be understated. All right, let's get on with it. I'm sorry.
Latest functionality that we've been building.
By the way, as I mentioned, I will link the video below. So if you don't want to hear me talk, just watch the video.
For Unreal Engine. So Jacob's here with the latest functionality that we've been building for Unreal Engine. So Jacob's here with us today in the Unreal Editor. Let's explore the environment. And what better way to do that than off-roading? And what better way to off-road than in a Rivian R1T?
Oof.
Now, Rivian uses Unreal to power their instrument cluster, including 3D visualization of their vehicles.
That's cool.
So we worked with them to bring the R1T to life in this experience.
It's got some real-world use
Head on
cases
out,
as well.
Jacob.
Sure thing, on my way.
All right. So we're building tools for interactive and dynamic worlds. So here we have chaos physics simulating rocks that tumble as we drive over them, leaves bend out of the way.
I was just about to ask, like, how dynamic this scene was. Meaning, like, if you drive over this branch, you know, is this completely static, or is this something that will crumble and break? Now, for the rendering side of things, that's not a big deal, just because, you know, Lumen will recalculate stuff kind of dynamically, and even though it might take like a few frames, it's still gonna be able to do that versus obviously just statically baked lighting, which used to be kind of more or less the norm back in the day, and we're shifting from that obviously into a more dynamic system. But I don't know too much about how Unreal Engine's physics, like their chaos physics system works, but like, you know, this might be like extremely high quality in terms of like how many triangles it's actually made up of, right? Because if it's nanite, then of course this could be like a million triangles, but you're not really going to probably simulate a million triangles in the physics system if you need to kind of have some kind of dynamic fracturing and actual physics as well. So that's why, like, I'm curious, like, if he drove off-road and actually went through stuff and broke stuff, whether or not that would kind of hold up, or tried to run over a tree or a rock. But they did mention, yeah, that the rocks obviously are dynamic. But anyway, maybe I'm just getting ahead of myself, because maybe he's going to do that. That would be cool.
And we also added some
See stuff's
real-time
moving,
fluid simulation.
rocks are moving a bit. Wow, fluid simulation. Yeah, I saw
We
stuff
worked
about
with
the
the team
water
at
looking really
Rivian
good.
to set up Unreal's chaos vehicle model to simulate the suspension of the truck and how the
Yeah.
electric motors drive each individual wheel. Chaos also simulates how the tires compress and deform, and Meta Sounds enabled the team to precisely resynthesize the sounds of the electric motors and mix them with the ambisonics of the jungle. So Rivian provided us with a highly detailed model of the truck.
Oh, good. Here we go. So this shows the nanite kind of, well, this shows triangles, right? It's interesting that these guys are black. So that tells me that maybe this isn't nanite, this foliage. Maybe, but see, this is, though. So that's weird that this is black. Maybe certain things are, maybe certain foliages are like nanite and some of them are not. But either way, it gives you like some indication of how crazy like detailed these scenes are.
About 71 million polygons that were able to render in real time thanks to nanite.
Right, so this model of the truck is 71 million polygons.
In real
And interestingly, he doesn't say triangles, he says polygons. And that is an interesting choice of words, because obviously they come down to being triangles at the end of the day. But if he's saying polygons, you know, obviously if you have polygons that have more like vertices than 3, then that's technically kind of more detailed when you convert it into triangles, because you have more than 71 million triangles. Like if this was quads, for example, this truck, then obviously when you convert that into 2 triangles, you kind of end up with twice the amount of triangles. So yeah, that's interesting.
Thanks to nanite.
I'm sure it probably is triangles, but...
Now, the Rivian not only looks incredibly realistic because of Lumen...
Why is this quality so bad? I'm on 1080p 60. I mean, this is IGN, so, you know, what do you expect?
But also its materials. And today, we're introducing Substrate, our new material framework.
Okay. Substrate.
And to better demonstrate it, let's swap
I swear I've been in this hall. I think this is the hall that they did the
paint
2018 presentation in. Well, it looks similar anyway.
Now, of course, you can't order a Rivian with Opal body panels, but Opal was the internal code name for this project.
Damn, that looks
and also a really great
cool.
demonstration of Substrate's capabilities.
Yeah, wow.
The base layer models the iridescence, refraction, and reflections that occur inside of an opal.
Yeah, so they got multi-layered kind of
on top
materials
of that
here.
is a layer representing the polished surface and how light is absorbed as it travels through that clear layer of varying
That
depth.
looks really good.
And now we can add back on the dust and dirt layers. And notice how the reflection changes when interacting with the dust layer, and that there are no artifacts along the transition from dirt to dust to opal. So Substrate is more expressive, enabling artists to create materials like this with different shading models and compose and layer those materials as they see fit. All right, let's head on out, Jacob.
On my way.
Yeah, and this is
In
a
terms of
real-time demo,
performance,
which is very cool.
Substrate materials that are similar to the current Unreal Engine shading model cost
Like
about
as
the
in it's
same.
live.
Similar to the current Unreal Engine shading model cost about the same. But now, artists have the freedom to author more complex materials for extremely detailed use cases, like in cinematics and in film. So we're going to drive under this fallen tree.
Yeah, that's the other thing that I keep forgetting about. Like, obviously, Unreal Engine is not just for games. You know, like film production. Like, you know, like Mandalorian used Unreal Engine a bunch, which that reminds me I should get around to watching season 3. But it's just so cool to also kind of picture the fact that these improvements will also be useful to that entire industry, right? It's not just for games and for real-time things. So sometimes, like, when you have a platform like Unreal Engine that is so like diversely used, like a lot of these features that might not even make sense to you as, like, you know, if you're into games and you're working in the games industry, you might be like, oh, that's not never gonna run because that's like terabytes of data and whatever. Like the film industry might be like, no, that's perfect for us, because obviously their product at the end of the day is a frame of video, and your product is like all the raw assets and everything that you have to bundle up with the game because you need to ship that. So it's two completely different sides.
Tree here, and everything that you've seen up to this point was painstakingly hand-built by the environment team at Quixel.
Yeah. See,
Everything.
that's what I was going to say. Like, the artists obviously did an absolutely amazing job on this, and it's crazy how much worse this would look without talented artists.
Since that fallen tree has been built using our brand new experimental suite of procedural content generation.
Oh, wow. Okay, that's awesome
Entirely
as well.
an engine that are flexible, deterministic, and artist-driven. Our guiding principle in building these systems was to empower artists to make tools for artists.
Oh, great. They're going to show this as well. Yeah, I was going to say, like, hand making stuff like this, like, whilst obviously you can get a really, really good result, especially if you have good reference material, like if they actually went out to the forest, you know, and they took some photos and they wanted to kind of recreate something like that, like that's really important to do, because when you have reference material like that, you can be like, oh, you know, there's clusters of rocks tend to be in this pattern, right? If you're just going from your mind and trying to like be like, oh, well, what does a forest look like? Yeah, I guess I can just put a rock there, or some dirt here, or some moss there, or a fallen branch there. Like that can be really, really difficult. Like you need to have some kind of reference, right, to create these scenes and actually make them look realistic, because otherwise they won't quite look right. But obviously that's very difficult and extremely time consuming and expensive when you think about the fact that those artists need to spend so much time on this, right? So obviously doing this stuff procedurally, which is what he's talking about, kind of having the computer having like Unreal Engine kind of be like, I'll just give me like a set of rules ultimately, and I will generate this for you myself. That can dramatically speed up workflows. And of course that could reduce some of the character from it, because if you think about like a forest, if you're trying to create a certain feel for a game and you really want it to feel a certain way, or it needs to look a certain way, or there needs to be like all these paths and trails, like you want to fine tune every aspect of it. Even if that's the case, like using procedural generation as a starting point and tweaking it rather than starting from scratch as an artist and building everything yourself, that's also a major help. And I'm also curious, like, because AI is becoming so, I guess, popular and useful, you know, these days with stuff like ChatGPT, like I wonder if you could just, you know, use the power of AI to be like, generate me a forest that actually looks real, you know, or like I want like this particular forest, you know, from like this place in Europe or something, like generate me that forest, and it will like automatically know like what trees to use, like how the environment and the climate kind of mutates that, I guess. That would be really interesting, I think, because you could probably get something that feels a lot more natural than potentially, you know, procedural generation, which can make things a little bit weird. But anyway,
So
let's see how
Jacob's gonna
it
go
works
ahead
here.
and add a procedural assembly to the world. And the cool thing is that it
wow.
communicates.
Look at those things appear.
Thank you.
Yeah, that's really
Yeah.
cool.
Pretty cool.
I mean, the thing is, like, you know, he's saying procedural assembly, and people are clapping, and like, yeah, it's cool and it looks great, and it's really cool to see a world this detailed and that realistic looking just being edited like that. Like, that's really cool. Like, just watching this is cool because you can't really replicate this in any other tool or any other platform, really, right? Like, to this quality as well. Like, that is really cool to see. But like, at the end of the day, what did he do? He dragged something in. Like, it's really hard to picture like what this actually is, you know, because obviously, like, even the thumbnail shows like that island kind of shape that he ended up putting in. So clearly, like, you know, how procedural was this? Like, I'm guessing the actual structure wasn't procedural, but I guess the way that it kind of integrated with the world,
So Jacob,
maybe,
going to go ahead
was
and add a
procedural.
procedural assembly to the
Because you can see like how it
world.
seamlessly blended. Actually, it's interesting to go through this frame by frame. Okay, so this is it popping in. So that's like the first frame. So yeah, not bad, right? But you can see there's no grass here or anything. And then as we go frame by frame forward, you can see here that grass just suddenly appears. The shading is constantly changing, probably because Lumen's recalculating everything temporally, kind of frame by frame. As the frames go on, it accumulates more and more data. And then suddenly these kind of things appear for some reason. I don't know, I guess that's governed in some rules, like inside the actual like blueprint or whatever that they've dragged in. And then yeah, some extra foliage appears and stuff. So I'm guessing, like, I don't know, like it's hard to really, because he didn't really explain it, it's hard to see the extent of the procedural generation for this particular asset. Especially because I have a suspicion from that thumbnail that it probably already existed. But it's still obviously really cool how it seamlessly kind of blends in with the environment like that.
And the cool thing is
Round
that
of
it
applause.
communicates with other nearby procedural elements in the scene.
Yeah, so that's what he's saying. It communicates with other nearby procedural elements in the scene, which is really the magic of it, I guess, because you can blend stuff in and just keep adding stuff into your scene seamlessly, which is really, really cool.
Like the creek bed. So let's say a designer comes by, wants to direct the player to drive to the left. Jacob can simply move the assembly to the right, and everything updates to accommodate that change.
That's really cool, yeah.
Game design is iterative, so let's say the designer comes back, wants to give the player the choice of going left or right again.
I mean, just to be clear, like, you know, the games industry has used tools like this like extensively over the last decade, probably. Like, procedural generation of things like paths, you know, has been around in Unreal Engine as well for a long time. And even something like, you know, for racing games, being able to like drag tracks around and have them automatically, obviously, you know, you're playing like a game like Need for Speed, for example, and that corner just feels, yeah, it's a little bit too slow. Like, I need to make that corner sharper. Like, you know, what are you going to do? Rebuild the whole section manually? Like, no, you'll just grab that kind of spline node or whatever, and you'll just push it this way. And then suddenly you get a road that looks more like that, and everything else has just, you know, kind of like what he showed here, everything else will just adapt, and it will procedurally kind of, you know, you'll be able to do that. Because otherwise, like, could you imagine like testing and tweaking racing games like this manually? I mean, I guess that's what they had to do back in the day. But like these days, like it makes sense obviously to create tools like that. And it's not like the hardest thing in the world to make something like this, like for a racing game, to make sure that like your track feels really good. And on the other hand, you'd probably want to make sure that it does feel good before the artists go in with their detailing and actually make the environment look like finished art. But I would say that the impressive thing that we're seeing here is not even so much like the interaction with the environment and everything, but it's just the level of quality that this, like, you know, this truly does look just like, I guess, perfect, right? It doesn't look like something that's been slapped on, moved around, and like in 2 seconds. It looks like something that's been worked on for like a week by a team. And that's really impressive.
Jacob can simply move the assembly back over. Now, the artist who created this assembly also added some additional handles that Jacob can use to art direct where rock slides occur. Allows him to customize the piece a little bit more, make it a little easier for the Rivian to...
Yeah, which is like, I was going to say, like, you'd probably also build in a bunch of tools to make this kind of tweakable in the way that you want, so that it can be like used, you know, within the context of the game or experience you're trying to create. And what that process is like, I don't know. And I'm suspecting they probably won't show that. So it would be interesting to see how, you know, you would go about creating the rule set that governs how this is kind of integrated and generated, as well as like these handles, you know, how do you make that happen?
Drive by. So we started by handcrafting that original part of the level to set the visuals and art direction for the entire piece. and then built out procedural tools that allowed the team to create a much larger play space much more quickly. Now let's see how we can use these procedural tools to make larger sweeping changes to the environment.
Oh, it looks so good. I just love the fact, like, this is one of the coolest things, I guess, about like Nanite, is just how you can just have, you know, those wide shots. I think that's really their most powerful shots, right? When they can just kind of drag the camera off and kind of, you know, you don't see any lotting, you don't see like popping, it just looks detailed, just looks great. Like, that's just amazing. I love that.
So Jacob, let's start by removing some of the trees in this area.
Absolutely, that's easy enough actually.
All right, a little too
yeah,
much.
this
Let's
is
add some trees back in.
Okay.
And let's also add in some cliff formations, give it a little bit more variability. So the procedural systems are all deterministic, as Jacob is experimenting with different sets of input parameters.
So he's got like, this is called PCG. Just trying to look at this. I'm guessing like, I don't know if this is a built-in thing to Unreal Engine or if this is like a custom blueprint or something that he's created that obviously, like, it obviously would be because these are very specific parameters. Maybe this is something that just kind of ships with the engine though as a
set that he
starting
likes,
point.
he can always go back to it and get out exactly the same results.
Yeah, because the seeds
And the
are
procedural
maintained, yeah.
systems aren't just placing trees and rocks, but also fog cards, bugs, birds, everything that's needed to bring this environment to life. And everything that you've seen here works at scale. This environment is 4 kilometers by 4 kilometers. If we hide all of the procedural elements, we can see that original hand-built area about 200 meters by 200 meters.
That's funny.
We believe that there will always be the need for hand-building environments, so we design these procedural systems
That's
to
good.
be tools for artists that work in concert with hand-built content.
Exactly. And that's what I was saying. Like, it's so good to have a starting point, you know, or like some kind of ability, you know, to use this with an actual artist, because at the end of the day, like, you know, this looks great and this would be great as like a backdrop, but if you imagine like a story driven game or something, like, you know, you're gonna have to have specific like visions that the art director or whatever, whoever's writing the story, might have, right? And obviously if it's difficult to be like, I want this exactly, you know, and I want this to feel like this, I want it to look like this, then, you know, it's almost like this procedural system doesn't matter and doesn't work well for anything other than like, I need to create some terrain for the background, you know, which again, usually would be crazy to have this level of detail for that, but because of Nanite and how it works, that might actually be feasible. So it's really good that you can use it
and the new procedural
together.
tools will be available in experimental form in 5.2. And everything you've seen here is running in the Unreal Editor in real time on a developer machine with an Intel 13900K CPU and NVIDIA RTX 4090 GPU. So
Yeah.
Jacob, thanks
So
for
pretty
being here and helping
beefy,
us out
but
today.
Thank you very much, Nick, for having me. It's been a pleasure.
that's to be expected. All right, so that's Unreal Engine 5.2, the presentation from GDC. Epic as always. Let me know what you guys thought of this video. If you want me to take a look at something else next time, and I will see you later. Goodbye.